A 4,000-acre lake can swallow itself. Not over centuries, not over years, but in a matter of hours. During the 2006 drainage of Lake Jackson, eyewitnesses reported seeing the final moments. A vortex, a literal whirlpool, opening up in the middle of the basin like a puncture wound in the Earth's skin. It began to spin, pulling in water, then mud, then entire sections of floating vegetation. They said you could hear the roar of it, a low grinding sound of billions of gallons of water finding an exit that was never meant for the surface world. An alligator, reportedly, was seen slipping over the edge, pulled down into the chasm. This is not mythology. This is geology. And in North Florida, just miles from the state capital, it is a geological process that is beginning to accelerate in terrifying ways. The most recent major event began not with a roar, but with a slow, relentless decline. An extreme drought settled over the Florida Panhandle in late 2021. The rain stopped. By Thanksgiving week, the water levels in Lake Jackson were already critically low. But gravity was not finished. Deep beneath the surface, the pressure from the underground Floridan aquifer, which normally helps support the lake's volume, was also dropping. The delicate balance was broken. In the lake's southern basin, a sediment plug inside a massive sinkhole known as Porterhole Sink began to fail, and 12 billion gallons of water began a journey straight down. By May of 2022, the transformation was complete. Where a 6.25 square mile body of water once reflected the Florida sky, there was now a sprawling, cracked mud plain, a post-apocalyptic landscape of drying lily pads and stranded tree stumps. And at the center of it all, a 28-foot deep pit, Porterhole Sink, the lake's primary drain, now fully exposed. News reports showed people, families, couples, amateur paleontologists, walking across the barren lakebed, their feet sinking slightly into the drying muck. They were descending into the sinkhole itself, a place that for years had been under immense water pressure, now accessible to anyone with a pair of boots. They were hunting for fossils, for artifacts, for a piece of the strange temporary world that had emerged from the depths. They called it Jurassic Park. And they found things. Mastodon teeth from the last ice age, pottery shards from the Muskogee and Seminole people who had lived here for centuries and gave the lake its original name, Okeeheepkee, the disappearing waters. In June of 2021, during another recent dry down, people wandering the exposed lakebed made an even more unsettling discovery. 2 human skulls, not evidence of a modern crime, authorities later determined, but remains of archaeological interest, another secret given up by the receding water. It seems the lake isn't just a body of water, it's a vault, and every few years the doors swing open. This is the part the aerial photos don't quite capture, the life that thrives not just in spite of the chaos, but because of it. While the bass and gar and bluegill get corralled into a few remaining deep pools, a new ecosystem explodes onto the mudflats. Seeds that have laid dormant for years suddenly germinate, creating a lush green carpet across the basin floor. Shorebirds, not waterfowl, become the dominant hunters. And deep within the sinkhole system, another form of life carries on, entirely unseen. It was here, in this cycle of wet and dry, that a team from Florida A&M University led by Dr. Thomas M. Sawicki made an incredible discovery. A new species, a tiny crustacean named Crangonix appalachii, closely related to blind cave amphipods. It wasn't just surviving the dry downs. This subterranean world was its native habitat. The lake disappearing wasn't an end for this creature. It was just another Tuesday. It's a strange temporary world that appears on the mudflats. Curious what you think this cycle actually means for Florida's future? Let me know below. To understand how an entire lake can become a fossil hunting park and a habitat for new species of subterranean life, you have to understand the ground beneath Florida. The state is not the solid slab of bedrock it appears to be. It is a world of dissolved limestone, a geological formation known as karst. Think of it as a massive, porous sponge. Rainwater becomes slightly acidic as it falls through the atmosphere and percolates through the soil. And over millions of years, this mild acid eats away at the limestone, carving out tunnels, caverns, and massive underground rivers. Lake Jackson sits directly on top of this system, in a 42-square-mile closed drainage basin in Florida's Red Hills region. It has no rivers flowing in. It has no rivers flowing out. It is essentially a gigantic rainwater cistern perched precariously on a foundation of Swiss cheese. Its existence is a constant negotiation between 3 forces: rainfall from above, evaporation into the atmosphere, and the immense, invisible pressure of the upper Floridan aquifer from below. The aquifer is a colossal underground reservoir, one of the most productive in the world, holding and transporting trillions of gallons of water. When the aquifer is full, the hydrostatic pressure pushes up, helping to seal the weak points in the lakebed and support the water above. But when drought hits, and when cities and agriculture pump water from the aquifer, that pressure drops, the support gives way. The lakebed itself has two major points of failure, two massive sinkholes that act as the system's primary drains. In the north, Lime Sink. In the south, the 28-foot deep chasm known as Porterhole Sink. For most of the time, these holes are plugged with a thick layer of sediment, muck, and organic debris. The Florida Department of Environmental Protection, in an almost poetic moment of bureaucratic clarity, describes what happens next. In their official FAQ, they state, "In the last stages, the lake appears to drain rapidly, as though someone pulled the plug from a bathtub." It's not a metaphor. The sediment plug blows out, and the full weight of the lake, billions of gallons of water, begins to funnel downward into the aquifer. A 4,000-acre lake becomes a 4,000-acre funnel. This is not a slow leak. Eyewitness accounts from the 1982 dry down reported the water level dropping multiple feet in a single day. The process creates a feedback loop. As the water drains, its weight decreases, further reducing the pressure on the plug and accelerating the flow. The final stage is a torrent, a cascade into the earth that carves out the sinkhole, clears out debris, and resets the entire system. And the water that vanishes isn't gone. It's just relocated. It's a system of geology that feels almost alive, operating on a scale we rarely get to see. If you find these hidden planetary mechanics fascinating, you can subscribe for more deep dives, like this one. The question of where exactly all that water goes haunted geologists for decades. For years, the connection was suspected, a piece of local hydrological lore. Logic dictated that the water entering the Floridan aquifer at Lake Jackson had to come out somewhere. The prime suspect was Wakulla Springs, a massive first-magnitude spring 19 miles to the south, one of the largest and deepest freshwater springs on Earth. But proving it, creating an undeniable chain of evidence, required a daring scientific mission. It required a detective story. In 2017, Dr. Sean E. McGlynn, a geologist and director of McGlynn Laboratories, decided to write the final chapter. He designed a tracer dye test, a classic method of tracking water flow, but on a scale that was anything but typical. The plan was audacious. They would inject a large quantity of non-toxic fluorescent dye directly into Porterhole Sink during a drainage event, and then wait for it to appear at Wakulla Springs. The chemical chosen was rhodamine WT, a brilliant red dye that is easily detectable in water even at microscopic concentrations. They would need a lot of it, 100 pounds to be exact. But there was a problem. How do you inject 100 pounds of dye deep into a violently draining, unstable sinkhole at the bottom of a disappearing lake? The answer came in the form of a professional scuba diver named Andreas Hagberg. On September 19, 2017, as water continued to pour down into the earth, Hagberg made the descent. He swam down 22 feet into the murky, turbulent water of Porterhole Sink, trailing a hose. For over 2 hours, he held his position in the abyss, physically pumping the vibrant red dye into the maw of the underground river. He was literally feeding a geological beast. Once the dye was in, the clock started. Dr. McGlynn and his team set up automated monitoring equipment at Wakulla Springs, 19 miles away. The instruments would continuously sample the spring's output, looking for the telltale fluorescent signature of the rhodamine dye. And so they waited. 1 day passed, then a week, then 2 weeks. The water at Wakulla ran clear. Had the dye been diluted into oblivion? Had it been diverted into some unknown cavern system? Had the entire theory been wrong? For 34 days, there was nothing. Then, on October 24th, 2017, 35 days after Andreas Hagberg's dive, the sensors lit up. The dye had arrived. It had traveled 19 miles underground through a network of limestone caverns, a journey that took over a month. The average speed of this hidden river was calculated to be about half a mile per day. The connection was no longer a theory. It was a proven fact, mapped and timed. The water of Lake Jackson was directly feeding Wakulla Springs. Every time the lake vanishes, it is undertaking a slow, month-long pilgrimage south, through a subterranean world of darkness and pressure, to re-emerge into the sunlight at one of Florida's most iconic natural wonders. The disappearing water of Okeeheepkee had finally revealed its destination. Now, here is the part of the story that alarms geologists and state hydrologists. A natural cycle is one thing. An accelerating one is something else entirely. For most of its recorded history, Lake Jackson's disappearances were a rare and generational event. The first documented draining by modern settlers was in 1829. After that, the record shows major dry downs occurring on a fairly regular schedule, roughly every quarter century. 1932, 1956, 1982. It was a rhythm the ecosystem and the people living around it had adapted to. It was predictable, spectacular, but infrequent. Then, around the turn of the millennium, something changed. The rhythm broke. The interval collapsed. Look at the timeline since 1999. Major dry downs, either partial or complete, occurred in 1999. Then 2006, then 2012, then a brief one in 2017, which enabled the dye test. Then a significant event in June 2021, and then the most recent one beginning in late 2021 and stretching into 2022. A cycle that once took 25 years to complete is now happening every few years. Dr. Robert Fulton, a Florida State University geologist who has studied the system for over 3 decades, has noted this unprecedented acceleration. The lake's historic breathing pattern has become a hyperventilation. The stakes of such a change are not theoretical. Just 130 miles to the southeast, near Gainesville, lies a stark reminder of what happens when karst geology and human infrastructure collide catastrophically. Payne's Prairie, now a beautiful state park preserve, was once a navigable body of water called Alachua Lake. In 1891, after a period of intense drought dropped the local water table, the main sinkhole in its basin, the Alachua Sink blew open. 20,000 acres of water drained away in just 6 weeks. The collapse was so swift and so total that it permanently stranded 2 active passenger steamboats in the middle of the new prairie. The boats, caught in the deep mud, were simply abandoned to rot. They stand as silent monuments to the immense power lurking just beneath Florida's surface. It's a reminder that the ground beneath our feet is not always permanent. Loki sent this to a friend who needs a reminder of that. So why is this happening now? Why is Lake Jackson's disappearance act becoming more frequent? There isn't one simple answer. It's a confluence of factors, a perfect storm of natural and man-made pressures. Dr. Alex Wood, a hydrologist with the Northwest Florida Water Management District, points to the increasing severity and frequency of droughts, a pattern consistent with broader climate change models for the Southeast. The extreme drought of 2021 that triggered the latest event is part of this trend. Less rain means the lake gets less input, and the aquifer beneath it gets less natural recharge. At the same time, the demand on that aquifer is growing. The city of Tallahassee and surrounding Leon County are growing. More people means more homes, more businesses, and more lawns, all of which draw water from the same Floridan aquifer that supports Lake Jackson. The more water is pumped out for municipal use, the lower the aquifer's pressure drops, and the less support it can offer the lake above. It weakens the foundation. It's a simple equation. Record droughts are starving the system of water from above, while increased development is draining it from below. The lake is caught in the middle. The accelerating dry downs are not a freak occurrence. They are a symptom, a distress signal from a regional water system under immense strain. The ripple effects extend far beyond the muddy shores of Lake Jackson itself. The 19-mile underground connection to Wakula Springs is now a conveyor belt for whatever is in the lake. When Lake Jackson drains, it sends a massive pulse of dark, tannic, nutrient-rich water directly into the spring system. This has been linked to periods of dark water at Wakula Springs, which can harm the native vegetation and overall water quality. Wakula Springs is already officially listed by the state as an impaired waterway, suffering from unrelated pollution issues. Receiving a month-long, 12 billion gallon injection of lake water only adds another layer of stress to that fragile ecosystem. There is a profound irony in all of this. For the lake itself, the dry down is a form of renewal. Biologists with the Florida Fish and Wildlife Conservation Commission, or FWC, point out that the process is ecologically beneficial in the long run. The drainage consolidates the loose, mucky sediment on the bottom, creating a firmer lakebed. The exposure to air and sun allows dormant seeds in the soil to sprout, leading to a massive growth of new aquatic plants when the water returns. This, in turn, kickstarts the entire food web, leading to healthier fish populations. The lake essentially cleanses and reboots itself. But this ecological silver lining is cold comfort for homeowners who watch their lakefront property turn into a mudflat, or for hydrologists who see the event as a blinking red light on the dashboard for the entire region's water supply. The health of the lake and the health of the regional water system are suddenly at odds. And then there is the existential question buried in the data. If a 4,000-acre lake, a prominent feature on the map for centuries, can now vanish every few years because of shifts in climate and groundwater usage, what does that imply for everything else built on this same foundation? The roads, the buildings, the entire infrastructure of North Florida is predicated on the idea that the ground is stable. But the karst landscape is fundamentally dynamic. It is a slow-motion geological dance, and it appears the tempo is picking up. Lake Jackson is the canary in the coal mine, and it is singing a very strange song. For now, the lake waits. As of late, 2022, heavy rains began to return, and the water started to refill the basin. The process of rebirth is underway. Hydrostatic pressure from the rising aquifer will combine with new sediment flowing in to once again seal Porterhole Sink. It always does. But no one can say for how long the seal will hold. Another severe drought, another year of heavy water extraction, and the plug could be pulled once again. The future of Lake Jackson is now a question of weather patterns and water policy. A single hurricane could fill it to the brim in 48 hours. A long dry spell could drain it again before the new vegetation even takes root. The cycle of Okeeheepkee continues, but its clock is broken. The ancient rhythm has been disrupted, and the new one is fast, erratic, and unpredictable. And so, three critical questions hang over this basin. How long until the next disappearance? At what point does the temporary dry down become the new, semi-permanent state of the landscape? And what does it mean for the future of Florida when a city's drinking water aquifer and a world-famous spring are now inextricably linked to a colossal bathtub with a broken drain? Somewhere, deep under the pine forests and suburban developments of Leon County, the last of the water from the 2022 drainage is still moving. It is flowing at less than a mile a day. A silent, invisible river navigating a maze of limestone it has traveled for millennia. In the darkness, the tiny blind crustaceans of the species Crangonix appalachii swim through the pulse of water, a hidden biosphere thriving on the change. Porterhole Sink is quiet for now, slowly plugging itself with mud. But the caverns below are full, and they are waiting.